One end of a light inextensible string of length 0.8 meters is attached to a fixed point O. A particle P of mass 0.3 kilograms is attached to the other end of the string. P is projected horizontally from the point 0.8 meters vertically below O with the speed 5.6 meters per second. P starts to move in a vertical circle with center O. The speed of P is v meters per second when the string makes an angle theta with the downward vertical. While the string remains taut, show that v squared is equal to 15.68 times 1 plus cosine theta, and find the tension in the string in terms of theta. Data's statement, our figure, we'll use change in mechanical energy is equal to 0. We can use this formula because the tension of the string is always perpendicular to the displacement, so its work done is 0. Here is the 0 level of potential energy, for example, and then this distance is equal to L times cosine theta. This is L, and the height at this point L minus L times cosine theta. So change in mechanical energy is change in kinetic energy plus change in potential energy. Final kinetic energy, initial kinetic energy, final potential energy, and m times g times height minus initial potential energy, divide by m, multiply by 2, and factor out L. And we get plus u squared minus this expression, and after substitution we get the statement. We have to find the tension. Let's see the forces. Tension of the string, gravitational force, we break down it, this is theta 2, so it's adjacent of theta, so m times g times cosine theta, and we can apply Newton's law. T minus m times g times cosine theta is equal to m times a. It is here, and now a is equal to v squared over r radius. Now it is L, and we get the tension, and after substitute we get that the tension this we have done. For the instant when the string becomes slack, find the value of theta and the value of v. So tension is equal to 0. We use our previous solution, it is here, so this is equal to 0. Minus 5.88 and divide by 8.82, we get this equation. This is a trigonometrical equation. We can use this first. We calculate theta null. Arcus cosine 0.667, not minus, 0.667. This is a temp degree, temp angle, and as cosine is equal, this is equal to negative, so it's in the second quarter, and there we can get the angle 180 minus theta null. It's 131.8 degrees. We can use our previous equation. It was here, v squared, it is here, so we substitute theta here. And square root, it is here, cosine theta, it is here, so we get that the velocity is equal to 2.29 meters per second. Find in either order the speed of p when it is at its greatest height after the string becomes slack, and the greatest height reached by p above its point of projection. Here is our figure. First, the motion is a circle, and here, from here, it's a free fall. So it's a parabola. This is the initial speed. It is here. We break down it, a vertical and a horizontal component. The horizontal component doesn't change, and at the highest point the vertical component is 0, so at the highest point the velocity is the same as the initial velocity, horizontal velocity. So let's see the angles. We calculated this angle. We get this 131.8 minus 90. It is here, and this and this angle is the same, and this is this direction is perpendicular here, so it is 90 minus 41.8, and this is adjacent, so Vx is equal to 2.29 times cosine 48.2. It is here, so this is the speed when the particle is at the highest point. Now we have to calculate this height. First we calculate this distance. Initial speed, this is it is here. We should use sine because this is opposite and they are the same, and the acceleration is minus 9.8, and we can apply this formula. V is equal to 0. At the highest point the vertical speed is 0, and after substitution and calculation we get S. This distance is 0.8 times sine 41.8, it is here, plus L. So we get that the solution is 1.48 meters.